Hey guys, in this lesson we will cover lesson 2-3, solving multi-step equations. By the end of this lesson, you should be able to solve equations involving more than one operation, and you should also be able to solve equations involving consecutive integers. So let's kind of dive right in and start looking at some examples. Now, before we start, I do want to talk about order of operations again. Now, remember, when we're solving equations, we're going to use the order of operations, which is PEMDAS. Okay, parentheses are some grouping symbols, exponents, multiplication and division, and then addition and subtraction. And we're going to work these order of operations backwards. So we're going to first see, is there any addition and subtraction? If there is, I'm going to get rid of it first. Then is there any multiplication and division? Then I'm going to get rid of that, and so forth. Okay, now when I think about the order of operations and working them backwards, I'm thinking about my variable. So whatever my variable is, I'm thinking what is not attached to these, or what is attached to these variables. Then I'm thinking addition, subtraction, multiplication, and division, and then exponents in parentheses. I'm working that backwards. So let's look at this first problem. I see I have 11a minus 4 equals 29. So my variable is a. I want to get a by itself. Okay, now I have 11 attached to a, which is multiplication. I also have minus 4, so that's subtraction. Okay, so what I'm going to do is I'm going to get rid of this subtraction first, okay, because it's not attached to my a, and I'm working PEMDAS backwards, and addition and subtraction comes first. So in order to get rid of this subtraction, I'm going to add 4 to both sides. Okay, now whatever I do to this side, to the left side of the equation, I have to do to the right side of the equation. So negative 4 plus 4 goes away, and I'm left with 11a on the left side. And I have 29 plus 4, which is 33. Okay, now I still don't have a completely by itself, so now I need to get rid of this multiplication. So now I'm specifically looking, well, I have 11 times a. I can get rid of 11 by dividing both sides by 11. Okay, so now I have a equals 33 divided by 11, which is 3. Now, the most important part of solving these equations, especially when it comes to multi-step, is checking my answer. So I'm going to go back through and plug a back in. So I have 11 times 3 minus 4. And I'm going to figure out what that is. Now I'm doing order of operations correctly. So I have 11 times 3 is 33 minus 4. 33 minus 4 is 29. Now I'm going to check and see if that equals the other side, which it does. So a equals 3 is my answer. Okay, for the next one, I have a plus 7 divided by 8 equals 5. Now let's talk about what's happening in this equation when I think about my order of operations and working them backwards. If I just look right here, I see that I have plus 7 and I have divided by 8, okay? Now, we would think that I would need to get rid of the add 7 first, right? But this division bar actually shows that I have some grouping symbols, okay? So what I'm going to do is I'm going to get rid of everything on the bottom first. So the way that I do that, so this is type of parentheses. So I'm going to do that very, very last, okay? So I need to get rid of this 8 first. So I'm dividing by 8 here, so I'm going to multiply both sides by 8. That leaves me with a plus 7 equals 5 times 8, which is 40. Okay, now I still want a by itself, so I'm going to subtract 7 from both sides, do the opposite, and I get a equals 33. Now, the most important part is checking your answer, so I'm going to plug 33 back in. I have 33 plus 7 divided by 8. Well, 33 plus 7 is 40. Divided by 8 is 5, and that does equal the other side of the equation. So A equals 33 is my answer. Part C, again, order of operations backwards, so I have addition and subtraction first. So I'm going to get rid of the subtraction by adding 6. What I do to one side, I have to do to the other. So I get 2A equals 10. Now I still have a 2 attached to this A, so now I want to do the opposite. I was multiplying, now I'm going to divide both sides by 2. And I get A equals 5. Now I'm going to check my answer by plugging it back in. So I have 2 times 5 minus 6. So I have 2 times 5 is 10 minus 6. That gives me 4. So A equals 5 is my answer. Okay, go ahead and try D on your own. Now this is very much like B. Okay, for D, I have some invisible parentheses up here, so I can't get rid of what's on the top yet. So I'm going to first multiply by a negative 2. So we'll multiply both sides by negative 2. And I get n plus 1 equals negative 30. Now I can use subtraction. So I go minus 1. Whatever I do to one side, I have to do to the other. So I get n equals negative 31. Now you should have checked your answer. So if you plug that back in, you get negative 31 plus 1 divided by negative 2. Negative 31 plus 1 is negative 30. Divided by negative 2 gives me a positive 15, and that does equal the other side. Okay, part E, I'm going to do the opposite. So 2 is attached to my x, so I can't get rid of that first. I'm going to subtract 11 from both sides. And I get 2x equals negative 8. Okay, now I can get rid of this 2. I want x by itself, so I'm going to divide both sides by 2. And I get x equals negative 4. Now I do want to check my answer, so I'm going to plug that back in. I have 2 times negative 4 plus 11. So 2 times negative 4 is negative 8 plus 11 is 3. So that is my answer. X equals negative 4 is my answer. F is very much like B and D, where I have these invisible parentheses, these invisible grouping symbols up here at the top. So now I'm going to go ahead and get rid of this 12 first. So I'm going to multiply both sides by 12. So those 12 cancel out, and I get K plus 9 equals negative 24. Now I'm going to subtract 9 from both sides. And I get K equals negative 33. So check your answer. Plug negative 33 back in. I get negative 33 plus 9 divided by 12 equals negative 33 plus 9 is negative 24. Divided by 12, that is negative 2. So K equals negative 33. Okay, go ahead and try the last two on your own. So pause this video and try those. Okay, what you should have done for G is here I have C divided by 3, and then I have a minus 7. Now this minus 7 is not attached to the C, okay? It's not a part of this grouping over here. So when I work my order of operations backwards, I am going to take hold of this -7 first, the subtracting 7. So I'm going to undo it by adding 7 to both sides. And I get C divided by 3 equals 9. Okay, now I want to undo this dividing by 3, so I'm going to multiply both sides by 3. And I get C equals 27. Now I do want to check. So I have 27 divided by 3 minus 7. 27 divided by 3 is 9. So I have 9 minus 7, which equals 2. So C equals 27 is my answer. For H, I have 14 that's not attached to this division at all. So I'm going to get rid of that first. Now this is a positive 14, so the way that I undo it is I subtract 14 from both sides. So I get negative A divided by 2 equals negative 20. Now, a common mistake is forgetting that negative in front of this division. Okay, so don't forget that everything that we didn't touch comes down. Okay, now I can get rid of this negative or this 2. Now I want to go ahead and do this in one step. So I can bring this negative down to this negative 2 and get rid of it altogether. So what I want to do is I need to multiply by a negative 2. So what that does is it gets rid of the 2 and it also gets rid of the negative. So I'm just left with A, which is what I want. So I have A equals positive 40 because negative 20 times a negative 2 equals a positive 40. Now I can plug this back in to check. I get 14 minus 40 divided by 2 equals, so I need to go ahead and do negative 40 divided by 2 is negative 20. So I have 14 minus 20, and that does give me a negative 6. So my answer is A equals 40. Okay, let's look at some word problems. So it says write and solve equation. So what we're going to need to do here is we're actually going to need to write the equation first, and then we can solve it. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $185. What was the original price of the skis? Okay, so they're on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $185. What was the original price? So I'm looking for original price. Okay, so what is the cost before the skis were bought before taxes? The sale price was $185. So I know this equals $185. Now let's talk about what went into this sale. So I have 2/3 of the original price. So that's what I'm trying to find. So 2/3 of the original price. And he used a $25 gift certificate. So what does that gift certificate do? It takes $25 off of that original price. So I'm actually going to subtract $25 from this. So here I have this equation that I was able to write from the problem. So I have 2/3 of the original price minus $25 equals $185. So now I can solve. This 25 is not attached to t, so I can add 25 to both sides. I'm trying to find the original price before the gift certificate and before the sale price. So I have 2/3 of T equals $210. So now remember from the one-step equations, I learned that if I have a fraction, I can go ahead and multiply by the reciprocal, which is 3/2, and that's going to give me what I need. So that cancels out the 3 and the 2, and I get the original price equals 210 times 3/2. And I get $315. Don't forget your units. If you put this dollar sign, that counts. Okay, part B. Lynn read 3/4 of a graphic novel over the weekend. Monday, he read 22 more pages. If he has read 220 pages, how many pages does the book have? Okay, so I have 3/4 of the total was read. Okay. Monday, he read 22 more pages. So I'm going to add to that the 22 pages he read on Monday. And then he read a total of 220 pages. So I have an equation here, and I can solve. So what I'm going to do is I'm going to subtract 22. If he didn't read those 22 pages, he would have only read 198 pages of the book. Okay, so that equals 3/4 of the total. Now I can multiply by the reciprocal. And I get the total pages of the book is 264 pages. Again, don't forget your units. Okay, go ahead and try part C on your own. So go ahead and pause the video. Okay, so Susan has a $10 coupon for the purchase of any item. She bought a coat that was on sale for half of its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? Okay, so let's talk about what we have here. First thing I want to do is figure out what it's asking me to find. Okay, it's asking me for the original price of the coat. So that's my end goal. Okay, that's what my variable is going to be. So we can call that T. Okay. Now she bought a coat that was on sale for half of its original price. So I have half, and then we're letting the original price be T. And she also has a $10 coupon. So I'm going to subtract off that $10. And that equals the $125 that she paid. So I can solve this equation now. I can add $10 to both sides. And I get 1/2 of T equals 135. Now I can multiply by the reciprocal, which is just 2. And I get T equals $270. Okay, now let's talk about consecutive numbers. Okay, so up here you see a chart. You have your number of terms, which means do I have 1 term, 2 terms, 3 terms, 4 terms, so forth, okay? The consecutive numbers, what they represent. So if we only have one number, we just call that one variable, okay? And in this case, we use n to represent number. If we have two numbers, I would have n, and then I would have n plus 1 for my second number, okay, and so forth. If it says that we have consecutive odd or even numbers, we're going to skip one, okay? So what we're doing is we're adding 2 every time we're kind of adding a new number in. And so let's talk about this. Let's think about some examples, okay? So if I have 3 consecutive numbers, let's talk about how this works. If I have 3 consecutive numbers, maybe I have 3, 4, and 5. Well, if 3 represents n, well, to get 4, I would have to add n plus 1, okay? To get 5, I would have to do n plus 2 because 5 is 2 away from 3. So this is how consecutive numbers work, okay? Now let's talk about some even numbers. If I have 6, 8, and 10. Now these are consecutive even numbers because they're right next to each other and they're all even. Okay, so 6, 8, and 10. Now if I let 6 represent n, well, how far away is 8 from 6? Well, it's 2. So that's why we do n plus 2. And then 10 is 4 away from 6, so I have n plus 4. It same works with odd numbers. Okay, so if I have 5, 7, and 9, these are consecutive odd numbers. If we let our first number 5 represent n, well, 7 is 2 away from 5, so I add 2, and 9 is 4 away from 5, so I add 4. Okay, now we can find consecutive numbers given a few details about what their sum is. Okay. So this first example, it says find 3 consecutive odd integers with a sum of negative 51. So I have 3 consecutive odd. Okay, so I'm looking directly at this chart here. If I have 3, I have n plus, well, n plus 2. If I'm looking at their sum, so I add them together, plus n plus 4. And that all of those summed together are going to give me a negative 51. So first things first, I need to combine like terms. So I have an n, and an n. Well, that makes 3 n's. Okay. Then I have 2 and a 4, which makes 6. Now this is set up exactly how we were working problems before, and all I have to do is solve. So I'm going to subtract 6 from both sides. That gives me 3n equals negative 57. Divide by 3. And I get n equals negative 19. Okay, now it says find the 3 consecutive odd integers. Well, I found one. I found the starting one. Okay. Now, in order to get my next two, well, negative 19 is n. Well, I have to add 2 to get my next one, which is negative 17, and then add 4 to my first one, and I get negative 15. So my 3 consecutive odd integers that sum to get me negative 51 is negative 19, negative 17, and negative 15. Okay, part B, find 3 consecutive integers with a sum of 21. So this is just consecutive integers. I don't have even or odd, so I'm looking at just this chart up here, n plus 1, n plus 2, and so forth. So I'm going to do these the same exact way. I have n plus 1 plus n plus 2, and that's going to sum together to give me 21. So I combine like terms. I have n plus n plus n, that's 3n, and I have 1 plus 2 is 3. And I can solve. So I'm going to subtract 3 from both sides. I get 3n equals 18. Divide by 3. And I get n equals 6. So I have my first consecutive integer. I need the next two. So I'm going to add 1 to that. I get 6. I'm going to add 1 and then I get 7. Add 2 to 6 and I get 8. And those are my 3 consecutive integers that give me 21 if I add them together. You can check your work by going back and adding them up. See if they give you 21. So I have 6 plus 7 is 13. Plus 8 is in fact 21. So that is my answer. Okay, I want you to try the last two on your own. So for the last two, we're going to find 3 consecutive even numbers, okay, that sum to give us 42. So the evens, I have n plus 2, n plus 4, n plus 6, and so forth. So I have n plus, need 3, so I do n plus 2 is my second consecutive number. And then I have n plus 4 is my third. And if I sum those all together, that gives me 42. So I can combine like terms, n plus n plus n, that's 3n. 2 plus 4 is 6. So now I can solve this like an equation, subtract 6 from both sides, and I get 3n equals 36. Divide by 3, and you should have n equals 12. Well, to get my next two even numbers, I'm going to add 2 to that, so I get 12, 14, and then add 4, which is 16. And the last one, find 4 consecutive odd numbers with the sum of negative 120. So here I have n plus 2 because it's odd, plus n plus 4, plus n plus 6. And that's going to give me negative 120. So I can combine like terms, n plus n plus n plus n, that's 4n. 2 plus 4 plus 6 is 12. And I can solve. So subtract 12 from both sides. I get 4n equals negative 132. Then divide by 4. So I get n equals negative 33. So I need to find the next 3 numbers. So I have negative 33. I'm looking at odds. I'm going to add 2, so negative 31. Add 4 to it, and I get negative 29. And then negative 27. And that's it.